Today we'll be talking on final and coarser topology and as well as comparable topology. Final and coarser topology and comparable topology. What is final and coarser topology? When we talk about final and coarser topology, definition: let Tor1 and Tor2 be two topologies. Divide on X. If each Tor1 open subset of S is also Tor2 open. That is, if Tor1 is a subset of Tor2, then Tor1 is said to be coarser. Our Tor1 must be coarser, smaller or weaker than Tor2, or Tor2 is said to be what? To be finer, larger and stronger. So it means this definition is talking on if you have Tor1 and Tor2 as a topology, divide on X. If each Tor1 open subset, that is the Tor1 elements having an open subset of X, is also open in what? It's also open in Tor2 also. That is, Tor1 is a subset of Tor2. That is, element that is present in Tor1 also present in element of what? Tor2. That is, Tor1 is a subset of what? Tor2. Then, if you have this related like this, we are going to say Tor1 is coarser because they are Tor1. A coarser means when a topology is smaller or weaker. But when we talk about a topology which is finer, that is, the topology is what? Is larger and what? Stronger. So when we talk about the final topology, we are talking about what? It must be larger and stronger. When we're talking about coarser topology, it must be smaller and weaker. So this is the definition of final and coarser topology. So let's go into comparable topology. When a topology is said to be comparable, so two topologies, Tor1 and Tor2 on set S are said to be comparable. It's either Tor1 is finer than Tor2 or Tor2 is finer than Tor1. That is, Tor1 is a subset of Tor2. So this is the definition for comparable topology. If you have two topology, Tor1 and Tor2 on a set S are said to be comparable. It's either Tor1 is finer than Tor2 or Tor2 is finer than Tor1. If you look about this, we talk about whenever we have a topology which is finer, we are talking about larger and stronger. That is, it's either Tor1 is larger or stronger than Tor2, or Tor2 is also larger and stronger than Tor2. If you can find this, it means what? We can compare it together. That is, they are both what? Finer. And if they are finer, it means what? They are subset. That is, they are open subset. Open subset of X, Tor1 is also open in what? Tor2. So that's why we have a finer. That is stronger and what? Larger. So example. If you have S is a members of real number, and we have our topology, Tor1 having X, having empty sets, then having a real number of X, then we have a open subset 2 and 3, and we have Tor2 empty set, a real number of this, then we have 2 and 3 as an open subset, then we now have 0 and 4 also an open subset. We can see here, we can see that Tor1 is finer, Tor2 also finer, but Tor1 is a subset of what? Tor2. That is, according to it's either Tor1 is finer than Tor2 or Tor2 is a what? Finer than Tor1. That is, Tor1 is a subset of Tor2. This case it implies that Tor2 is finer than what? Than Tor1. So we have considered this example. That is, Tor2 is stronger than what? Subset. The subset is talking about that element that is present here. Element that if you look Tor1 and Tor2, the elements are the same, but Tor2 is having only 0 and 4 open subset that is not present. Since this one, we can find this one here, we can find this here, we can find this here. It means what? Is a subset. That is, Tor2 is a subset of what? Tor1 is a subset of Tor2. Tor2 is a finer than Tor1. So this is a comparable topology, and this is a what? final and coarser topology. One is stronger and one is what? Weak. One is stronger, one is weaker. So when you have a stronger topology, it must be a finite. When you have a weaker topology, it must be what? Coarser. So this is the comparable topology and what? Final and coarser topology. Thanks for watching.